Hello everyone, thanks for joining me today. My name is Tanner Palin, and today we'll be doing a deep dive into the smart grid applications for blockchain. I will start off by introducing you all to some of the blockchain and smart grid research performed according to the smart grid conceptual model developed by the NIST. Then we will look into some of the benefits blockchain may be able to provide to the smart grid through its structure and the subdomains where the smart grid can benefit from blockchain implementation. Lastly, we will end with my opinion on the viability of blockchain being used in the smart grid. The National Institute of Standards and Technology has developed a decentralized conceptual model for the implementation of blockchain technology in smart grid applications. This conceptual model leverages the incentivized trust aspect of blockchain to create a decentralized platform for future smart grid development. Blockchain can be used to provide certified, tamper-proof data to the smart grid operators. This data can then be used to determine the development of their demand response management systems. Now we will look deeper into some of the aspects and features of the blockchain that stand out if applied to the smart grid. The first aspect of blockchain I would like to look into is the decentralized peer-to-peer network that it is able to provide. This means that there is no single leader or source that could control the market or be attacked to take down the smart grid. I use this image of a workplace to kind of act as an analogy and show the differences between a centralized or decentralized system with a boss as the central source of power versus a more dispersed and decentralized source of control in the workplace. Another feature of the blockchain that could potentially benefit the smart grid is its trustworthiness. The blockchain replaces traditional trust with mathematical and computational forms of trust. Consensus protocols prevent double spending or trading, and the distributed ledger adds resilience and prevents any tampering of data. In order for these features to take hold and be applied in the smart grid, an incentive needs to be distributed to those upholding the blockchain. This can be done through cryptocurrency or maybe providing energy credits due to the immense power consumption of some blockchains that will not be named. Now we will dive deeper into the decentralized smart grid model that's been developed by the NIST and some of the subdomains that are poised to benefit from blockchain implementation. On this slide, you'll see an image that represents the NIST's decentralized smart grid model, and within this model there are some of those areas or subdomains that are going to potentially benefit from blockchain being used. On this slide, you will see a summary of the analysis that has been performed on some of the different subdomains that exist within the NIST smart grid model and where they can benefit from blockchain implementation. On the rightmost column, you can see different types of blockchain that could be used for the respective subdomain. BCAAS stands for Blockchain as a Service. This could be outsourced with a third party, potentially providing blockchain as a service. One of the subdomains within the NIST smart grid model that could benefit from blockchain is metering. Decentralizing this process of collecting and verifying the consumption of energy will add resilience to the grid and reduces bottlenecks in the grid's performance. Bottlenecks could come up as many different items need to be monitored and the meters need to be read. Consensus-based data on these electrical loads can ensure that resources are being allocated properly for the development of energy infrastructure. Another domain within the NIST conceptual model that could benefit from blockchain is the electric vehicles domain. As electric vehicles become more common, an electric vehicle with a significant enough battery could act as its own broker of energy with the smart grid. The vehicle could automatically sell and buy energy during the peak and off-peak time periods within the smart grid. This could potentially make profit for the owner and further increase the distribution and resilience of the grid. I'm not quite sure how this would affect the battery life of the vehicle, but through some cost analysis it may prove to be a good idea for the owner of the vehicle. The peer-to-peer trading network that blockchain is able to provide could support this trading of energy through the smart grid. Just like any other network, the smart grid is susceptible to many forms of attack. System exploits, scanning attacks, and the theft of customer or utility credentials could put the smart grid in a bad position. Currently, these attacks are all mitigated through a central system or utility. There can be many different inefficiencies in a central system trying to secure all of the many different types of devices that would make up a smart grid. Through all the different smaller microcontrollers to the larger substations, there are many different types of devices that will go into the smart grid. The peer-to-peer network within the blockchain can provide multiple points of protection from attacks and prevent them from happening altogether. And this will be more easily achieved through the decentralized security network as opposed to one large central defender of all attacks. Now that we've looked into the different ways blockchain could benefit the development of the smart grid, we need to figure out if this is currently a viable solution. Personally, I think that the viability of blockchain for the smart grid depends on how much power it would consume. It seems like it would be counterproductive to spend too much energy just to provide energy. I think that time will tell, and the efficiency of electronics are always improving, so it may be a solution one day to defending the smart grid. Thanks for watching this presentation. I hope you were able to learn a few things about blockchain and how the smart grid may benefit from it. Here are some of the sources I used when developing this presentation. Thanks.